Hello, everyone. Welcome to another episode of Generative Geek. We are continuing with the Chroma DB series. And so far, what we have done is we learned in the previous video on how to create Chroma DB, how to install it using Python, then how to create persistent clients, how to use OpenAI embeddings, and then using the OpenAI embeddings and the persistent client, how do you go out and create a collection? Then we added a few items to the collections. We got them back using our get command. We also retrieved the collection using get collection. We saw how many items were there using the count method. And then we did a peek in the end where we were like, okay, if we had to look at the first 10 items, how do they look like? And we saw that, when you do a peek, you could also see the embeddings that were part of it as compared to when you do a get, right? So this is what we have done till now. Now in today's episode, what we are going to do is we are going to take a Netflix data set. We're going to take the first 1,000 rows from it, and the Netflix dataset that I'm going to use is the Kaggle dataset. The link for that is available in the description of the video. But if you go to this if you go to the link, all you have to do is just download this file. It'll give you a zip file, unzip it, and get the CSV. That part I have already done, and I have kept the Netflix underscore titles.csv ready for me for processing here. Now when we have this, what we'll do is we'll look through the data set first. We'll load it through using pandas, and then once the data set is loaded, we'll start creating some sort of an enriched information string, and I'll talk about why we do that and how we create the enriched information string. Then using that string as a document, we will ingest documents. We'll use the various things we have learned till now, like the count method and the peak method. We'll do all that. We'll figure out how many documents are there, how many collections are there. We'll look through the first 10 and all of that. Then we'll view some documents using the get method. We'll update the collection by adding metadata information. This is something that we have not touched till now, but we'll be doing it in this episode. Now it will allow us to do more powerful queries, and that you will see as part of the video, how we do the metadata updates, and then how do we retrieve collection and make query searches using the metadata embeddings that we have done. Once everything is done, I'll show you how to delete the collection, and that will be the last of it. So this is the agenda for today, so let's get started. So first steps first. Now we'll go out and start importing all the necessary libraries for us, because the Netflix title CSV is already available with me. If you still haven't downloaded, this is the page where you need to go. And once you are on this page, click on this download button. This will give you a zip file, and then unzip it and get the CSV. Keep the CSV where your notebook is, and let's get started, right? So we'll import pandas as PD, and then we'll say df is equal to pd.read csv. This is the method that you use when you want to read the CSV file using pandas. And I'll say Netflix underscore titles.csv. We'll run this. I'm getting no module name pandas found. We'll just install pandas. This is the new environment, and therefore, maybe the imports were missing, the installs were missing. Now that I have installed, I expect it to take a little while, but yeah. So now this is done. We'll quickly look through the data frame to see what kind of data has got loaded. So we have show ID, type, title, director, cast, country, date added. Now this is the entire CSV, right? Going back to our scope, we will take the first 1,000 rows from this data set. Maybe not the first, but we'll just process this data set a little, and we'll look through the data set. We'll use pandas for this, and then once the data set is ready for processing, we'll create enriched information string. So let me just show you what I mean by that. So let's first quickly look at the data set. We'll do a df.info and see what the data set looks like. So if you look at it, there are a few empty rows, like cast and country. Those column values are missing for certain fields. Even the date added is missing. So just to ensure that we get back this experimentation goes all right and you learn, I'll just drop any row which doesn't have any of these column values. So df is equal to df dot drop na in place is equal to true, And what it does is, if you now look at the df info, you will get that we have all of the column values are available, and there are 5332 rows. Now what I'll do is I'll say that, hey, I don't want to ingest this entire data set, because that probably has no meaning as such. So what I'm going to do is I'm going to take the first 1000 rows, and I'll say df is equal to df up to first 1000 rows. That's now my subset. And I'm going to create a new list called Netflix underscore info. This is a blank list for now. And this is the list where I'm going to store my enriched string. What I mean by enriched string is, if you look at this data set, right, there is show ID, type, title. But when I want to actually store document as a document into the data set, the title and the description, a combination of these two makes a lot of sense for me to store as a document. Everything else, if you look at it, what is the type, who's the director, what was the release year, what is the rating, that all becomes some sort of a metadata for this string, right? So I'm going to create a string, and I'll loop through the entire data set, and I'll say for index comma row in df dot iter rows. This is how you loop through a data frame. I'm just going to append to the Netflix list. I'm going to append a dictionary which has an ID, which is nothing but a show ID. No, I'm not going to append an ID. So this is not what I want. I would rather just have, I don't want to append a dictionary. I'm sorry. I rather want, so sometimes what happens is ChatGPT will give you something and you start believing that that's probably right. I don't want that. I rather want that the title, and that's what I was just discussing with you, that I want the title, and I want a separator, and I'll add a description, right? So the title and description, these two things is what I want to add to the Netflix info, right? And IDs for me is nothing but df.index.as type str.toList. So what I'm doing is I'm just taking the IDs from the data frame and using those IDs itself. So I'll run this, and now you can see, let me just quickly run Netflix info and print the first five. You can see this is how our list now looks like. So Sankofa is the name of the movie, and then this is the description in the new line. Again, the Great British Baking Show is another movie or a TV show, and then this is the description. So this is how each of our list entry is looking like now, right? And this becomes my enriched string. So each of this is basically my this becomes my document. And the ID, if you look at it, I'll just print the first five IDs: 7, 8, 9, 12, 24. Those are my first five IDs, right? So they become my IDs. Now what we'll do is we'll go out and we'll just quickly delete the collection. So we already have the collection that we had created yesterday. I'm just going to use the same collection. What was the name of the collection? It was called new collection. So I'm just going to retrieve that same collection. So the way you retrieve a collection is you say client dot get collection, and you pass it the name. Our name was new collection, and you then pass it the embedding function. And our embedding function, so this was the name, and our embedding function is openai underscore af. That's the embedding function we had created. So okay, now the challenge is that this notebook is from the previous episode, but I have not yet ran the same thing again. So let me run everything again, so that there is a context available, right? So, and that is okay. I'll just leave this error for now because it says this is already available. And I'll not do much after this, because all I wanted to instantiate was the client. The error we got this time was that it did not know what a client is, right? So I have fixed that error now, and it has been able to get the collection for me. Okay, I should have referenced it to some variable saying, hey, collection is client dot get collection. And now using the client collection that we have, I can say collection dot add, and this is how you add your documents, right? So documents is equal to Netflix underscore info. Now if I press enter, Now what is happening is, okay, it's saying that some existing embeddings were available called id1 and all that. Okay, why is it saying id1? uh, I should not have done that, but okay. Part of learning is that when you type something, you realize that you should not have done it, and that's all right, right? So what we'll do is we'll do collection dot upsert IDs is equal to IDs, and documents is equal to Netflix info. Upsert, like I told you in the last video, what it does is it's like an update or create. So if an ID is already existing, it will force an update. If an id does not exist, that will get created, right? So collection dot upsert. Now if I do collection dot get, and I'll say ids is equal to ids, first five ids I want to pass, I can see that it got 12, 24, 7, 8, 9, and these are the first five movies, right? That part of the document that it has pushed. uh, okay, so I hope this has been clear till now. We have not done anything new. All we have done is just created a collection. Let's quickly see how many items we have. So I'll do a collection dot count, and we have 1012 items in this. Now let's just quickly start seeing how do you go out. So now our database already has some information. As a next step, what we want to do is we want to now go out and start querying the database. So what I'll do is I'll form something called as a query text, and that's like a list. I'll say maybe my query is going to be that where the main uh, character is a detective, right? So let's just say if this is what I'm trying to query, I'll say result is equal to collection dot query, and I'll pass in the query text, right? So query text is equal to query text, and top underscore k is how many results you want. So I'll just say n underscore results is equal to 5, and that's what we pass. So we want to get back 5 results, and just see what results come back, right? So so here, if you look at it, it's giving me some IDs, it's giving me some distances, and it's now giving me some documents back, right? So it does not default by default give any embeddings. It's giving me documents, right? So department, so first item is the movie is called, or the show is called Department. Two cops form a task force to take down two mobsters and all that, right? So brick mansions, an undercover police detective. Small town crime, but a disgraced ex-cop discovers a dying woman. I am all girls, a relentless detective, right? So you can see what is happening behind the scene is, if you remember our vector database and embeddings lectures, what is happening is that we are using an OpenAI embedding function, query text. When you use the OpenAI embedding function, the query text will be converted into an embedding. Next, what will happen is the distance is going to get computed between the query text embedding and the embeddings present in the collection, right? So you have these two different vectors. You are going to do some sort of a the database is going to do some sort of a cosine distance or a Euclidean distance, or some other method of calculating distance between these two, and whichever is less, it will say, hey, you know what, these are the lowest distance objects, and it's going to return those five, right? So, and this is what the distances list has, right? So it indicates their closeness in terms of semantic similarity. What we can also do is we can even pass a list of queries. So if you saw here, we had one query. Let me just quickly change this and say, hey, where the main character is a detective, or I can even say where the story is about a young girl, right? So let's just say, right, I don't even know what mode I'm going to get back, right? So let's just see, right? And it needs to return five results, right? But because there are two lists, so you can see that the IDs get returned for the first query and then for the second query. So you will in total get 10 documents back. So the department and all that, this is about probably about the first one. In the cut, after embarking on an affair with a cop probing the murder and insular, this coming of age charmer follows the summer in the life of an 11-year-old girl. This is most probably the second one, right? So now the second query that we had. My girl to a teen to make surprising discoveries. So you saw, like, if you give like a list, you might have anything, any query coming to your mind. You might say, hey, you know what, this is the kind of movie I want to watch now. You can give it that you can give that as a query and expect some interesting results back. Now this is when we have only ingested 1,000 rows. There were like some 7 8,000 rows in that data, in the original database. We have only ingested 1,000 rows. Now let's just do this. Now let's what I'll do is I'll pick maybe 383 and 343. So I'll say, hey, picked or selected IDs is equal to 343, and what was the other one? It was 383, right? So these are the two IDs that I'm going to pick. And next what I'll do is I'll say my reference text is collection.get. I'm going to basically get values for these selected IDs. I'm going to get the documents back. And the way to get the documents back is, first let me just show you what we get back. And then it's nothing, it's very simple Python. When we get this thing back, I want the document. So I'm just going to write documents in front of it. Right. So these are the list. These are the items we get back. I can just say for text in reference underscore text, print text, right? Right. So these are the two movies that we got back, right? My Girl, This Coming of Age Charmer, and Department. Like these were the two IDs, right? So now what I'm doing is, once we have the reference text, I want to now take these two movies and pass some sort of a where clause, right, within the query object. So we have been forming this query object here. I just want to enhance the query now, right? So I'll say, hey, you know what? My query is nothing but result is collection.query. Query text is reference text. We formed the reference text here. So I'll probably just use those two. And I'll say end result says maybe 3. And I want to add a where clause. Where? So the way you add a where clause, if you have ever worked on Mongo, it's very similar. You just add a dictionary. And so we'll say where type is movie, right? And next we'll print the result. Okay, so see, I did not get anything back this time. And the reason I did not get anything back is because there is no metadata available. All we did was we had initially just done some sort of um title and description string formation, and we inserted that. We never inserted any metadata into it. So the first thing when you want to do more complex queries is that we need to update the metadata. And the way to update the metadata is that the same way that we update the documents, we now need to update the metadata. So let's first do the metadata updation, and then come back to these type of queries where we'll form a query saying, hey, you know what, I want to find movies which are about detectives, or I want to find TV shows about detectives, right? So those kind of things you will be able to do once you have updated the metadata, and I'll show you quickly how it works. So let's do the metadata update. For that, what we'll do is, same way that we created the Netflix underscore info enriched string, I'm going to create a new list called metadatas and create an empty list here. Now we'll again loop through the database, loop through the data frame, and we'll say for index comma row in df iter rows, what I want to do is I want to update. I don't want to update the title. I don't want to update the description. I want to update, and let's just quickly look at the data frame once again, right? So that we know what all we want to update, what all metadata we want to update inside the in the database, right? For every document there is a metadata that can be added, and our where clauses are going to act on these metadata. So I'm just going to use them now. So type is important for us. So we'll use type, and then we'll say type is nothing but row type. We want the type. What else do we want? Do we want anything else? Yeah, we will take maybe the country. Country will be interesting. So we can say row country. Yeah. We can even add something like a release year, release underscore year. Yeah. So let's say this is what we want to add into our metadata string, right? We have this complete. Seems like some arrow. Okay. Yeah. So with this, now my metadata string is ready. We can quickly see how it looks like. I'll just quickly print the first two. And you can see the first two. First is a movie where the country is United States, Ghana, Burkina Faso, United Kingdom, Germany, Ethiopia. I don't know. Maybe it released in all these countries in one go, right? So um, what we are trying to do is we are just trying to pass some metadata information so that our queries can be enriched, right? That's my whole goal with showing you. I haven't done a thorough analysis of the database of this data set myself. Now, once the metadata string is ready, I'll also quickly just look at the len of IDs that we had created earlier. We have 1000, and len of metadatas is 1000. They have to be all of the same length, otherwise the update will fail. And now once we have that, we'll just say collection dot update IDs is equal to IDs and metadatas is equal to metadata, right? So once you do this, when we were updating documents, we had done documents is equal to Netflix underscore info, if you remember. Now we are updating the metadata. So I'll just press this. Now what should have happened is, I'll just quickly show you collection dot get IDs is equal to reference underscore no, there was some IDs that we had got, selected IDs, right? So I want to just IDs is equal to selected IDs. Now, if you look at them, earlier when we were querying, if you see, all we got was we were only looking at the documents, but we never got any metadata back. Now, if you look at it, each document has some metadata associated with it, and this will now help us get even better results, right? So the query that we had put in earlier, where our result was based on some sort of a where clause, let's run that same query again, right? Now, if you look at it, I did not get back an empty string. I got back some result, right? Because it there was where the type is movie, and my query text was based on this reference text that we had got. This was the reference text. It is able to go out and find some interesting movies for us, right? So it is able to say, hey, you know what, this is these are the movies. We can even say, if you look at it, IDs, country, this is all metadata, and then we can come back to the documents part. There has to be, yeah, documents, right? So if we just do print results dot documents, okay, Dictochet has nothing called documents. uh, okay, we'll get to it in a while. I don't want to waste your time while I'm debugging. So we saw that, if there is a simple type of a query that we want to do, in the sense where, hey, this is my reference text, go out, find the closest matches, but only those which are movies, I was able to do it. But let's just say if I want to do even more complex matches, like, something like, hey, can you find me movies where the release year is greater than 2015, and maybe where the country is United States and it closely matches the reference text. So let's just see what happens when we do that kind of thing, right? So how do you do that? We'll say result is equal to collection. We have the same collection. We'll make a query, and our query is still the same. Our query text is same as reference text. Now look at it that, we look at it this way, that while our reference text is still very very limited, we only have two strings there, right? But if you have like a production system, your reference vector can itself be a very decent size, right? So uh, and then you will get better results. But this, for demonstration purposes, I think even this is all right. um, uh, so n results is 3. Let's just pick the first 3 results, and we'll now add the where clause. Where clause, the logic is very simple. You put a where, then you create a dictionary. And what I'm going to do this time is I'm going to create a logical operator combination. So we'll say where and and from here you create a list. What kind of an and do you want? So our and is that, we want, the first is where type has to be a movie. So our type has to be a movie. Next, what we want is, sorry, this is not the right way. I should have said type is $eq movie. This is how you define your queries here, like, your operators here. Next, we'll say, um, where a country dollar eq is United States. Yeah. So, and then we'll also say where release underscore year. Now, so far we have been doing more equals. Now, this time we want the release year to be greater than. So, with greater than, you put $GTE, and $GTE is greater than 2015. So, this is what we want from the, this is the query that we want to run. Now, our query is formed. We'll just quickly go out and print the results. Collection got an query underscore text. It should be query underscore text. Oops, it should be result. Right. So this is what we got back. Now, if you look at the metadata for everything, everything is a movie, right? So, and every result that we got back will have a release year greater than 2015. So, and you can see how close they are. So the first one is, let's look at the in this uplifting musical, a troubled teen takes a leap of faith by attending a summer camp. Like, maybe this is about that young girl, right? Desperate to save his 11-year-old gunner, runs away from home. He's compelled to track down her killer. So this is that detective one, a secret service agent. So we had, like, this is what we are getting back for each of the query, for each of the string. We are getting back three results. I hope this helped you understand how you can now go out and create complex queries. Similarly, what you can also do is, you can even have a delete or a delete operation, or we can even do an or operation here. Like, instead of an and, I could have as well said that, hey, take all of this and put an or here, right? So instead of an and, maybe you want an or, like, hey, any of these matching, I want the result. So let's just run this, and you will see this time around some things will match but not all. So this, in this combination, a movie match happened, but the year is 1991. Similarly, where some country is Philippines, it's not United States. So these ways you can create very complex queries, and you can do more complex retrievals back from the database. Now, let's just say you don't want any of these IDs, right? You want to delete these IDs. Let's just say hypothetically. So what you can do is, you can say collection dot delete. I'm now going to delete these IDs, and you will say IDs is equal to, you will give it the list of IDs that you want to delete, and you can just go out and press, you can run it, and those IDs will get deleted, right? So this is how you delete the documents from the collection. What you can even do is, you can pass more complex, like, when we were doing retrieval, we passed complex logical queries. Same way you can pass more complex queries for deletion as well, right? Let's just say you want to delete the entire collection. The way to do it is, you will say client dot delete collection, and you will give it the name. You will say, hey, new collection, I want this entire thing gone. Press enter. This entire thing is gone now. So if you do a collection, it is there. And if you do a count, It's not, nothing is there, right? So it says, hey, you know what, I don't even know what you're talking about. So this is it, guys. I hope, yeah, you got some sense of Chroma DB. In the next video on Chroma DB, we'll do some sort of a multimodal search where we'll ingest images, we'll run embeddings on them, and then we'll do queries like, hey, give me photos of dogs, give me photos of where there are street signs, or where there's some sort of a street festival happening. So it'll be an interesting one. Embeddings is a very powerful concept in general, so I really recommend that you watch the embeddings playlist we have, and it'll really help you get better understanding of how embeddings work. Thank you so much.